Okay, in this video, we're going to look at the problems from the lesson 211 homework assignment. Okay, problem 2.5. For each equation in parts A through D below, find the input value that gives the smallest possible output. In other words, find the x value of the lowest point on the graph, then find the input value that gives the largest possible output, or the value of the highest point on the graph. So, these two graphs are parabolas, so parabolas open either up or down, so we'll write this out here. That's an upward opening parabola. This is a downward opening parabola. So this would be the minimum value here. This is the minimum, and this is the maximum value. So what we want to do is find the x value. So these have the points x, y. So what we want to do is find the x value for the points that give me the largest and smallest or minimum and maximum values. Notice how a parabola can only have a minimum or a maximum value. So, in this one, okay, so we can start by making a table. Okay, so that's one way to do this, x, y. So I'm going to start with -4. No, not -4, sorry. I'm going to start with, let's see here, 0, 1, 2, 3, and 4. So I'm going to plug in zeros, 1, 2, 3, 4 in this equation. So I get 0. I plug 0 into here, I get -2 squared, which is 4. Plug 1 into there, I get -1 squared is 1. 2 gives me 0 squared, which is 0. 3 gives me 3 minus 1 is 2. And 4 gives me 2 squared, which is 4. So if you were to plot those on a graph, right, so here's 2, 0. So you know that 1, 1 is a point in the graph, and 3, 1 is a point in the graph. And then 0, 4, 1, 2, 3, 4, and that'd be over here. So you see the graph opens upward. So the minimum or the smallest value for y will be down here. So the x value that gives me that is x equals 2. But because the graph goes upward forever, there is no largest value, so that would be none. Okay, so for B, same thing. Make a table. So this case, because there's no x in the parentheses, I'm just going to do my standard -2, -1, 0, 1, 2. So -2 squared is 4, 4 plus 2 is 2. -1 squared is 1. 1 plus 2 is 3. 0 squared is 0. So 0 plus 2, whoops, messed up there, doesn't make sense. Let's try this again. -2 squared is 4 plus 2 is 6. That makes more sense. -1 is still 3. That's 2. 1 gives me 3, and 2 will give me 6. So you can kind of see if I graph this over here, 0, 2, 1, 3, -1, 3, and then -2 is 3, 4, 5, 6. So that'd be up here. Let's see the graph opens upward again. So the smallest value for y occurs when x is 0. And again, this opens upward, so there is no largest value. So there's no x value that gives me the largest value. Sorry, my handwriting is getting pretty bad, so let's write that as largest. Okay. Part C. Okay, so we got x plus 3 squared. So make a table. This time I'm going to start with -5, -4, -3, -2, -1. So I make these tables and the x inside the parentheses. I like to use the opposite of that number, put that in the middle of my table. So let's start with -5. So -5 minus 3 is -2 squared is 4. So -4 minus 3 is -1 squared is 1. -3 plus 3 is 0 squared, 0. -2 plus 3 is 1 squared is 1. -1 plus 3 is 2 squared is 4. So you can see the symmetry. If I plot those, this will be my smallest value here. And you can see how it goes up from there. The y values get larger. So the smallest value on this graph will occur when x is equal to -3. And again, because I go up and now left to right of this value for x, the graph seems to be going up. So the largest value, there is none. Okay, let's try this again over here. So now we got negative this. So again, no parentheses. So my standard -2, -1, 0, 1, 2. Okay, -2. So you always square x first and apply the negative. -2 squared is 4, makes it -4 plus 5 is 1. -1 squared is 1, and it's a -1 plus 4 is 5 is, sorry, -1 plus 5 is 4, good. 0 squared is 0, 0 can't be negative, 0 plus 5 is 5. 1 squared is 1, -1 plus 5 is 4, then 2 gives me 1. So now you can see how this is the largest value now. Largest, and as I go left and right, the value gets smaller. So there is no small value in this case. That means the graph does not open up because there's a largest value at x equals 0. That means the graph should open down. And so, party, where on the graphs of each of the above equations would you find the points with the largest or smallest values? Well, whenever I have a graph that opens up or down, okay, got the smallest value there, and we get the largest value there. Maybe you remember this from Algebra 1 or another class, but the points where the graph changes direction on a parabola, that is called the vertex. So the vertex. Okay, 2.6. We're going to sketch 3 graphs on the same set of axes and then ask ourselves, what does the negative coefficient do? So let's start with x squared. I'll put this in black, so I'll graph this in black. So x squared, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Then I can reflect those points. You get those. So there is the graph of x squared. I'm going to do the next graph in red. So I'm going to take x squared values and then multiply between my -3. So start with 0. So I get 0 squared is 0 times -3 is 0. Whoops. Okay, so we'll start with 1. 1 squared is 1. 1 times -3 is -3. Okay. And so start with 2. 2 squared is 4. So 4 times -3 is -12. So that's like down here somewhere. Then I can reflect these points. So here and here. So this graph looks a little bit skinnier and it looks like it opens down and not up. So that's interesting. And so we'll do this last graph in bluish color. So remember, -2/5 is really a fourth. So I'm thinking about it as y equals -1/4 x squared. So you can look at it that way. And so I'm going to take x squared and times the y values by a fourth essentially. So 0 squared is 0 times a fourth is still 0. So 1 squared is 1. 1 times -4 is a -4, so that goes there. And so this point will go here. So start with 2. So 2 squared is 4, and a -4 of 4 is -1. 3 is 9. So a fourth of negative 9 would be, sorry, negative 1/4 of 9 would be negative 9/4, which is negative 2 1/4. So negative 2 1/4 right here. And so I can probably keep doing this, but this will go an hour like this. As one's significantly wider. And so what does the x value do? So what does a negative coefficient do? A negative coefficient. So whoops, put coefficient. I must want some coffee right now. So a negative coefficient reflects the graph across the x-axis. So in a parabola, it has the parabola open downward. So that's what it looks like to me. Even though the number coming out a skinnier and a wider parabola, they both open downwards. That's what the negative number must do in front of the x squared. Okay, 2-7. We're going to use the results from this problem to help us with our investigation in lesson 212. So we really want to understand this problem. So we're going to draw a graph of y equals x minus 3 squared. Doing it by hand, we want to only use the domain of values of x between 0 and 6. You can see on my graph, I only have 0 through 6 on my x-axis. So we're going to make a table. Okay, I'm going to go 1, 2, 3. So 0, 1, 2, 3, 4, 5, and 6. And let's kind of fill it out. So 0 minus 3 is negative 3 squared is 9. 1 minus 3 is negative 2 squared is 4. 2 minus 3 is 1. Negative 1 squared is 1. 3 minus 3 is 0 squared is 0. Then they repeat. So we got 0, 9. We got 1, 4. 2, 1. 3, 0. 4, 1. 5, 4. And 6, 9. And we connect the dots, so we always make sure our arrows and ends of our graphs are outside of the coordinate plane. So when you graph these parabolas, try to do it without lifting up your pen. And so there is the graph of that parabola. Part B, how is the graph different from y equals x squared? So if I look at the graph, it looks like y equals x minus 3 squared is the graph of y equals x squared. So the same graph, but it's been shifted to the right 3 units. If you go back and look at the picture he drew, you'll notice the vertex was at 0, 0 for x squared, but now it's at 3, 0. And you can kind of, if you took that graph and you can translate it to the right geometry term, 3 units just to fit right on top of my new graph. Okay, so we're going to skip 2a and we're going to go to 2.9. So 2.9 is to write an equation for each graph. So we got the first graph is a line. We know it has a y-intercept right there. So the y-intercept looks like it's at negative 4. And then I can use that to find the slope. So take my intercept, pick another nice point. It looks like it's right here. So we need to make a right triangle, slope triangle. So I go down 2, right 3. So my slope is down -2, right 3. Since I have a point and a slope, I can write a slope-intercept form. So the equation of this line would be y equals -2/3 x minus 4. So B, it's a horizontal line. So what's true about horizontal lines is no matter what point I pick, let's pick this point here. That is going to be at the point -2, 2. And what you'll notice is that the y values will always be the same on a horizontal line. There's actually no slope. It's flat. It has no rise, but it has a run. So no rise over any run. Okay. That's still going to equal 0. So the slope is going to be 0. So we could write it as y equals 0x, and it clearly goes through the line at axis at 2. But we don't like to write the 0x. That's a 0. And so horizontal lines are the value y equals 2. So y equals whatever number it goes through the y-axis at. Okay, C, we got a vertical line. So vertical lines like horizontal lines. So there's another point. That's the point 2, -2. And like the horizontal lines, vertical lines have the same x value. But look at this has a run forever but no rise. So the slope is some rise over 0 run. But we've learned back in the day that we can't divide by 0. So we have an undefined slope. So I can't use an m value. I can only use a b value. Sorry, no b or m values. But what happens is because all of the points on this line have the same x value, the vertical line, we always write it as an equation x equals, and the value of x they'll share in common. So this every point has an x value of 2. So the equation of this line would be x equals -2. So part D is another line, not vertical or horizontal, but notice how it doesn't go through a nice value here for the y-intercept. I'm given 2 points. So this one we're going to find the slope first, and then we'll use that to find the intercept. This is probably something you're really used to. So we're going to find a slope. So the slope is the change in x over the change in y. So I like to label this as x1, y1, and x2, y2. And you may know the slope formula. The slope formula says y2 minus y1 over x2 minus x1 is how you find slope. So y2 in this case is 2, y1 is 0, so 2 minus 0 over x1 is 7 minus 4, so 2 minus 0 is 2, 7 minus 4 is 3. So slope is positive 2/3. And so now that if I want to write it in this format, which is the standard way we'll write all our lines in this class, I need to find B. So I can pick one of these. I'll usually pick the first point. When you let this be my x and y values in this formula, remember x and y is any point on the line. M is my slope, so I'm going to plug it in. So I know y is 0. That should equal the slope of 2/3 times x, which is 4, plus b. So I'm going to solve for b. So when I multiply fractions, you always multiply the top by the number I'm multiplying the fraction by. That number gets multiplied by the numerator. So multiply those together. 2 times 4 is 8/3. So to get b by itself, we can subtract. So 2/3 and 8/3 are not nice numbers, so we always leave in fraction form. So my equation is y equals 2/3 x minus 8/3. You can see how my -8/3 is about 2 1/4, sorry. You can see how I go 1, 2, and a little bit. So, sorry, it's 2 and 2/3. So you can see how that line's about 2/3 of the way between 2 and 3. So I feel pretty good about that. Okay, so next one, with the slope of AB is 5, with point -3, -1 is A, and B is 2n. So I'm going to find the value of n. So I can use my slope formula to find this. So I know, again, slope is y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. So I know that the slope is 5. So 5 should equal y2n minus y1 is -1, so minus and negative is positive, over x2 is 2, minus x1, negative 3. So negative 3 is positive 3. So let's see what I get. So I get 5 equals n plus 1 over 5. Now, I need to get rid of this fraction. So anytime I want to get rid of fractions in equations, multiply both sides by the common denominator. So I have one denominator, it's going to be multiplied by 5. So 5 plus 5 is 5. So you distribute this through each part of the equation. 5 times 5 is 25. These 5's cancel, leaving me n plus 1. So subtract 1, so n is 24. So n has to be 24. Now I need to find the distance. So the distance formula says the distance between 2 points is equal to the difference in the x-coordinates squared plus the difference in the y-coordinates squared, the square root of those. So this is a variation of the Pythagorean theorem. So I'm just going to plug in my notes. So remember, y2 is n is 24. So the distance is going to be, okay, we got x2, which is 2, minus x1, which is positive 3, minus the negative is positive, plus y2 is 24, minus y1, so minus negative 1 is 1, square root of that. So plug this in my calculator. Whoops. So I get 2 plus 3 squared plus 24 plus 1. Sorry, let's do it again. 2 plus 3 squared plus 24 plus 1 squared. So this would be 650. So let me show you a couple ways of doing this. So first way is to figure out what that is as a decimal. So I'm going to take my calculator, the square root of 650. Whoops, square root of 650. Now, we always want to round unless it's told differently in this class to the nearest 4 decimal places. So we're going to go 25.4951. That's one answer. That's the approximate value. Can you get the exact value, okay? We can reduce the radical. So what you do is you're going to think of what is the largest number, perfect square that goes into 650. Well, I think I'm going to go 25 because I know 50 is divisible by 25. So 650 goes into divided by 25 is 26. So this is really equal to square root of 25 times 26. Now there's a property that says the square root of a product is equal to the product of each factor. Sorry, the square root of each factor separately. So I'm going to square root of 25. Well, square root of 25 is 5, so it gets brought out front. Now 26, now that's not divisible by any other square root I can think of besides 1. So it's left underneath there. And so that's the exact reduced value. So we got 25.4951 as one possibility, or 5 times the square root of 26 as the other possibility. Okay, hopefully this helped. Again, go back and fix your problems, bring questions you didn't quite understand in class, and then that should help us out. Okay, we'll see you in the lesson 212 video.